we discussed that in the refraction, diba, it seems like this. Nga mura siyang nabali. This one also nga nabali siya. So this is called the refraction of light. So why is there refraction? So refraction of light is there because the light is being bent as it passes from one medium to another. So in that case, bakit nga ba siya nag-bend? Di ba we discussed last time that there is a difference in the speed of light. So ngano naman pud nga na ay difference in the speed of light? It's because of the difference of the density, no? Difference in the density of the different media. Ibig sabihin, if light will travel from air to glass, lahi-lahi man siya og kanang density. So lahi-lahi siya og the molecules are different, no? I mean, like example in air, they are slightly farther far away from each other, while in glass, which is a solid, medyo duol-duol siya. So lahi-lahi sila og density. So I will repeat ha, the refraction of light depends on the bending of light. I mean, is the result of the bending of light. And the bending of light is the result of the changing of the velocity or the speed of light. And ang speed of light, the difference in the speed of light, that is also the result because of the difference in the um, densities of these kuan kanang different media, no? Mo na siyang atohang gihisgutan kay ang reflection man is the bouncing back, so ni balik, but the refraction is the bending of light, meaning ni pass through na ang light from one medium to another. So ni pass through na siya, nilapus na siya bali. Okay, this is also another example. Now it is described in terms of this, no, mao ni siyang ato ang gi-discuss last meeting. We have there the normal line. The normal line there is the reference. Muna siya diha lang siya magbase sa ato ang asa dapit magbend ang light. So mo nang gitawag na siya sa normal line. In this case, we also discussed the small letter n, or what we call as the index of refraction, which is basically the speed of light in vacuum, which is constant 300 million meters per second, divided by the speed of light in that material. So in mathematical sense, we have there n is equal to capital C divided by the V. We had the sample problem last time, so you can answer this, no? Kay para kuan ninyo, review po ninyo inyong self. So I will read it to you. What is the index of refraction of a material if the speed of light in this material is 298,999,000 meters per second? So we have the formula N is equal to C over V, which is N is the index of refraction, and the C is the speed of light in vacuum, and the V is the speed of light in that material. So if we're going to solve it, no, ang gipangita nato actually is the index of refraction. So I want you to solve it on your own para review pud mo. So in this case, we will be using the formula. So it is 300 million meters per second divide 298,999,000 meters per second, and the answer should be 1.003, no? So I want you to answer it on your own para makabalusad mo. Okay? So next problem is, what is the speed of light in zircon if it has an index of refraction equal to 1.923? So we use the same formula where n is the index of refraction, C is the speed of light in vacuum, and then V is the speed of light in the material. So we're looking for the speed of light in the material kani. Ha, mo atong gipangita. So I want you to answer it on your own, but if we're going to solve it, this should be 300 million 1, 2, 3, 1, 2, 3, 1, 2, lapas naman siguro ko. 300, 1, 2, 3, 1, 2, 3 million divided by 1.923. So the answer here should be 156,006,240.2 meters per second. So i-try ninyo na on your own para makabalusad mo. Then after that, we discuss the different index of refraction, no, of the different materials. So we have there diamond down to air. So I asked you last time, no, By the way, the value of the index of refraction will be given in your exam. So in your exam, nakabutang na sa dito, all you need to do is to solve na yun. You don't need to memorize it. So I asked you last time, what is the relationship between the n or the index of refraction of the material to the speed of light in that material? And the answer is inversely proportional. Buot pasabot, the higher the value of your n, the slower the speed of light in that material. So buot pasabot, the diamond, for example, and zircon, mas dako mag-value si diamond. Subot pa sabot, dako siyang value sa N, hinay ang pag-travel ni light dito. Si zircon, kay gamay-gamay raman siya og index of refraction, so mas fast ang pag-travel ni light dito kang zircon. So let's apply that. So brain twisters, no? So example, there is an air there and water, and light traveled from air to water. N1 is the index of refraction of the first medium, asa gikan ang light. And 2 is the index of refraction of the second medium, asa padulong ang light. Okay? So in this case now, the in which move or in which medium light travel faster man. So in this case, light travel faster in air. So let's read it. The higher the index of refraction, the slower the speed of light in that material. Now since water has higher index of refraction, mas hinay mo travel ang speed of light here, or mas hinay mo travel si light here. So if we're going to get a source, for example, a flashlight, if we turn it on, we can see there that the light bends, no? Mabend siya. Theta sub 1 is the angle of incidence, while theta sub 2 is the angle of refraction. So ganito, um, you will only take note of the angle of refraction. Do not mind the angle of incidence, kay kanira man imong focus. If the angle of refraction is smaller than the angle of incidence, ang tawag nato ana bent away, ay bent towards. So sa Bisaya pa ni gamay ang angle. That's bent towards. Pero if the angle of refraction kay ni dako, we term it as bent away. Sa Bisaya pa ni dako ang angle. So bent towards ni gamay ang angle, bent away ni dako ang angle. But we're only focusing on the angle of refraction. Okay, so ganito. I will read this to you. If the index of refraction is high, the light bent towards the normal line. So in this case, the index of refraction of water is larger. So kung tungod kay the index of refraction is larger, the speed of light is slower sa water. Unya kay slower man ang speed of light, mas gamay siyang angle. Tanawon nato si air. Si air kay gamay man og value sa index of refraction. So the speed of light is faster in air compared in water. Unya kay faster man siya, therefore mas dako siyang angle. Oh, so nakita ninyo, smaller, so faster ang speed of light. Kung faster ang speed of light, mas dako siyang angle. Diri kang water kay dako man ang value ni n, so slower ang speed of light. Since slower man ang speed of light, gamay ra pud siyang angle. So again, you will only take note of the angle of refraction. If the angle of refraction is shorter, or I mean smaller, we term it as bent towards. If the angle of refraction is larger, we term it as bent away. Okay, so let's have one more example. If, for example, meron tayong ethyl alcohol tsaka water. N sub 1 of ethyl alcohol is 1.510. N sub 2 is 1.360. I will repeat. N sub 1 is the index of refraction of the first medium. Saan galing yung light? N sub 2 is the index of refraction of the second medium. Asa man pud padulong ang light. So mo na siya buot niya pasabot. Okay, in this case, in which medium man light travels slower? The answer is okay, very good. It's ethyl alcohol. Kasi nga, I will read this to you again. The higher the index of refraction, the slower the speed of light in that material. Subot pasabot, light will travel, samta kung gayong na, slower ba? Oh, basta. Light will travel slower in ethyl alcohol compared to water. Kasi nga, dako siya og index of refraction. So if we're going to get a source of light, let's say flashlight for example, and then we turn it on, what do you think? Bent away or bent towards ang angle of refraction? What do you think? Okay, so if we turn it on, makita nato nga nidako ang angle of refraction. So your answer should be bent away. I will repeat, you only focus on the angle of refraction. Kung ang angle of refraction ni gamay, we term it as the bent towards the normal line. Pero kung ang angle of refraction ni dako, we termed it bent away from the normal line. Okay? Now, let's check. Mas gamay ang index of refraction ni water. Therefore, faster ang speed of light dinhaa kang water. Therefore, mas dako dapat siya og angle. So, ibig sabihin, let's try to check. If the index of refraction is high, the light bent towards the normal line. So, kana lang gid ang inyuhang tan-awon, no? So, in this case, the water is lower man ang value sa index of refraction. So, dapat bent away siya. Kani kay larger man ang value sa index of refraction, do dapat bend towards siya. But again, you only focus on the angle of refraction. Okay?